Finally, today we'll be doing some arithmetic. Whole week I was waiting for this too. So this whole week we took time out to explain the various concepts leading up to this, working on the area of a triangle. We look at geometry on Monday, we look at plane shapes on Tuesday, we look at the area, not the area, but the concept of area and perimeter of a triangle yesterday, and the day before that, I don't know, we look at some other concept on Wednesday. Today we're going to do a part one of three videos because each one will address the different formulas for calculating the area of a triangle. And today our main focus is half base by height. Let's go. Our objective, calculate perimeters of triangles. Oh yes, I forgot that. Perimeters included too. And we're going to also calculate the area of a triangle when given the height. And again, remember from yesterday's video, in order to use half base by height, we must get the height. If we don't get the height, then we have to know which other strategy to use. So let's go. So here we have an example, but again, you could pause it right here and you could go ahead and do it. You don't have to wait for me to do it first, or you don't have to wait until I do it. So how do we address this one? First of all, we need to do two things. We have to calculate the perimeter and we need to calculate the area. Area and perimeter. What is the perimeter? We said the perimeter is the distance around the shape. And in this case, to get the distance around the shape, we can simply add. So let me start with the perimeter since it's an easier operation to do here. So for the perimeter, all I need to do is add 13 centimeters plus 12 centimeters plus 8 centimeters. Easy does it. And if I do that, my result's supposed to be what? 12 plus 8 is 20, 20 plus 13 is 33, right? So it's 33 centimeters. So that's my perimeter, just like that. Area, no. Remember, for the area, there are three formulas for the area, but we have to know the conditions. In this one, if we want, we could use Heron's formula. Why? Because we're given three sides. But again, our focus today is half base times height. And guess what? That could work here too, because we're given the height and we're given the base. So let's work with that. That's our focus for today. So area, I usually like to encourage students to write the formula first. So I'll do it too. So half base by height, and then I substitute my values. So that is half multiplied by the base, which is 8 centimeters, multiplied by the height, which is 12 centimeters. When I do my maths here, half of 8, sorry, will be 4 centimeters multiplied by 12 centimeters. And this is why units are squared when we find any area. I don't know, sometimes some students don't understand this. But look at what is happening here. 4 is being multiplied by 12. And that will give us 36. Yes? But notice, centimeter is being multiplied by centimeter. And that is why whenever we find in the area, we will always get a unit squared because we are multiplying a unit by another unit. And if I might go further, for those of us that don't understand the index, I'll do a simple example here. So if I have x squared, for example, that is the same thing as x multiplied by x. If I have 8 squared, for example, that will be 8 multiplied by 8. And if I have cm squared, by example, that will be cm multiplied by cm. So that is what we had here. Cm multiplied by cm gave us cm squared. So that is why you realize, again, as I said earlier, whenever we find the area of any shape, the units will usually be squared because a multiplication of some sort from one unit to another will be taking place. And that is why the units are squared. Let's try example number 2. And here I try to change the orientation. We have to get accustomed to seeing this in different, from a different angle. Not all the time your quote-unquote triangle will be lie down or stand up, as we see, or as we don't see. Right, so let's try this one again. Let me change the color. So perimeter again. Remember, perimeter is the distance around the shape. So in this case, we have what? 6 centimeters plus 9 centimeters plus 7 centimeters. And if I add this, let's see what I get here. So 9 plus 6, that is 15, and 15 plus 7, that is 22. So 22 cm. And notice when we find any perimeter, we do not square the units because we simply add it. So it's like we adding boys in a class. 1 boy, 2 boy, 3 boy. Okay, let me say 7. So 6 boys, 9 boys, 7 boys. At the end of the day, it will just be, okay, 22 boys. So we just add in the units. So there's no need to square it. But when we multiply the units, yes, we need to square it. Good? So for the area now, again, notice that we're given the height and we have the base. So we have here now half base times height. And I replace values now. So my base here will be 7. So half times 7 times, let me put my units, half times 7 cm times 10 cm, which is equal to, right. If I find half of 7, I will end up getting a decimal. And right now, I really want to work with decimal. So I will find half of 10 instead. And again, because of the properties of multiplication, this is okay. We will get the same thing. We will get the same answer. You could prove it if you want. You could multiply 3.7 by 7. Sorry. Okay. Okay. Let me do that. So we have 3.5 cm. 3.5 is half of 7. Okay. Multiply by 10 cm. Let me just do it that way. And again, here because I'm multiplying by a 0 unit, I could simply move the point in this direction, right? Easy does it. I could just look at it that way, right? So then my answer here would be 35 cm squared. So 3.5 by 10 and cm by cm. What I was trying to show you earlier, what I was trying to tell you earlier, that in a case like this, because when I find half of 10, it's a lot easier. You're getting a whole number instead of avoiding the 3.5 when you find the half of 7. So I was about to say instead of finding half of 7, find half of 10. So that would leave me with 7 cm multiplied by 5 cm. Yes? So I found half of 10 instead of 7 so that I could end up with a whole number. And notice when you do that, you will still end up with this answer here, right? Because 7 times 5 is the same 35. So it's up to you. I know some persons believe that, and again, it's how you're taught. Some persons believe that you must find half of the base. No. In a case like this, and again, it's because of the properties of multiplication. Multiplication is commutative, and commutative simply means this. If I have half, let's say, oh, let me use the same formula. So I have half multiplied by b multiplied by h. Multiplication, because it's commutative, nothing is wrong if you say this. Half multiplied by h multiplied by b. That is what commutative means. Even if you change the positions, the answer would not be affected. The same thing happens when you're adding. So if you add it, for example, and I'll use numbers now. So 5 plus 3 is the same answer you would get if you do 3 plus 5. And as we know, both of these will give you 8. That would not change the answer. Same thing happens when you multiply. Let's look at it. 2 times 4 will give you the same thing as if you had 4 times 2. And of course, in this case, we get the same 8. So with the formula, the same is true. So you don't necessarily have to find half of the base. If you find the height is an easier number to work with, go right ahead. You wouldn't be wrong. Good. And this will be our activity here, and this is our last question for today also. And I just change up the unit just to let you know that it don't always have to be cm. Sometimes you will see millimeters, sometimes you will see meters. Who knows? Maybe you might see kilometers one day. I don't know. I can't remember ever seeing kilometers. But who say it cannot be? Right. So here now again, same concept. I know a lot sometimes big numbers throw off students, but the concept is the concept, and let's just apply the concept. Don't worry about the size of the number. Perimeter is the distance around, so it's 50 millimeter plus 90, I said 90, but I write 99, 90 millimeter plus 120 millimeter. And if I add this, let's see what I will get. So 90 and 50, that should be 140, and 140 and 120, that should be 260. Hope that's right. If not, don't lose trust in me because I can't add. Yeah, but that's it. But again, for safety, for safety, let's do it the long way so that people will see what we do. 0 come down here. 5 and 2 that is 7, 7 and 10 that is 16. So I see where the 6 come from already. And this one add with that 2 and I get that. Yeah, so alright. Think capacity. I don't have it off yet. To get a calculator when I'm doing these videos on it. Right. So at least I could confirm quicker. Anyway, so the area now again, we're given the height. Notice this is a right angle triangle. They didn't tell us, but we could see it. And if it's one fact you should know in advance, in a right angle triangle, the side facing the 90 degrees angle will always be the longest side in a triangle. Always. And this is something I also proved literally growing up. I just draw a 90-degree angle. Well, when I learned to construct it, I construct it. But I had my own way of making sure that the angle is 90 degrees. And I just draw a line, I draw another line, and then I make the other two lines meet. And it doesn't matter the size you draw. Goodness gracious. This side always ends up being the longest in truth. This side facing the 90 degrees. Oh, maths is interesting. Right, so we have half base times height. And in this case, let's see, we're going to end up with a big number here. So we have half multiplied by 90 millimeter. Oh, well, actually the base. Well, again, it goes back to what I said. It's commutative, so it doesn't matter. The base is actually 50, but I put 90 instead, but it doesn't matter. I already looking at the easier way to calculate. And then we have, oh my, I'm jumping the gun, 50 millimeter, right? This will be the same as 45, so half of 90 is 45 millimeter. 45 millimeter multiplied by 50 millimeter. And let us just do a little long multiplication there. So let's see what our area will be. I will work it out over here. So 45 multiplied by 50, just for us to see the answer. 0 times 5 is 0, 0 times 4 is 0. 5 times 5 is 25, and notice where I'm lining up my 25. I have 2, okay, let me write it, so 25, and 5 4s are 20, plus that 2 there is 22. So my answer is supposed to be 2250. That's the area there. So the area of this shape is supposed to be 2250 millimeters squared. Ooh, love math. Yep, and that's it. Of course, you have to show your working at all times. Even if you use your calculator, never deny showing your working. It's no excuse for not showing working. And that's the end of today's video, people. So that's how you find the area and perimeter of any triangle using half base by height. So the only condition that needs to be met here is, of course, we must be given the height and we must have a base. And most times you get your base, but not always you will get a height. For all the triangles that, oh, sorry, I'm tired. Sorry about that. For all, well, it's Friday, right? For all the triangles that we did today, of course, Heron's formula could have also worked because we were given 3 sides. But I did that on purpose because I wanted to focus on the perimeter too. But next time, you know, once you have options, you could use your options if one is proving to be more difficult than the other. Like always, share with your friends, share with your classmates, share with somebody who's doing math. Like if you haven't as yet, subscribe so that you'll know when the next video comes through the notification. And comment if there's something you like, something that's not clear, something that you want clarification on, and feel free to do so anytime. Until next week, where we'll continue with part 2, which is Heron's formula. You take care.